Hello learners, welcome to another lesson. I'm teacher Anis and we are still looking at the chapter 3 of Form 3 chemistry. It is organic chemistry and we have been looking at alkanes. We have seen the nomenclature, the isomerism, and now we are going to look at part 4, which is the physical property of alkanes. So we start by looking at the first one. So physical properties is what we can observe or what we can see with our eyes when we look at these alkanes. So physical property number 1 is that alkanes are colorless gases. So as we prepared these gases, the first 4 alkanes, we saw that they were colorless gases, and we have prepared this in our laboratories, and the first 4 are gases and they are colorless. The second that is the second part of the alkanes, that is the next the first one is the first 4. The next part contains the 6 alkanes in order from the 5th to the 10th. That one gives us the solids, and then from all those that are above decene are liquids, and they are all not poisonous, so alkanes are not poisonous. So we have said methane, ethane, propane, and butane are gases. The next 6, that is pentane, hexane, heptane, octane, nonane, and decane, these are solids and liquids, and the rest are solids. So from 11, carbon atom number 11, all those are solids. Physical property number 2, they are not soluble in water. So the alkanes, we saw that we can correct them through a method known as overwater method because they are insoluble in water. So if we are told to explain why they are insoluble in water, we say it's because they lack opposite polar charges to those of water, but they are highly soluble in inorganic solvents. Okay, physical property number 3 is about the melting and boiling points. The melting and boiling points increases as the carbon chain increase. So the melting and boiling points of butane is higher than that of methane and that of ethane. This is because of the increase in van der Waals forces. So the intermolecular forces that join the carbon atoms together, as it increases, this one also increases the what? The melting and boiling points. The fourth physical property is on density. The density of the alkanes increases with the increase in carbon chain. This is as the intermolecular forces increases. So as the carbon atoms increase, it also increases the what? The intermolecular forces. So this one reduces the volume, and you know the relationship between density and volume. So this reduces the volume occupied by a given mass of the compound. Okay, so this is a summary of the physical properties of alkanes. So we can see for the first 4 are gases, the next are liquids, and so from the 10th we have the decene, those are from the 11th alkane, those are solids. Then the density, you can see the first one is 0.4, 0.54, 0.579, 0.6. So it is increasing as the number of carbon atoms or the carbon chain increases. What about the boiling and the melting points? The melting and boiling points also increases with increase in the intermolecular forces that is caused by the increase in carbon chain. Okay, so let us look at the chemical properties. The first chemical property is burning, or what we call combustion. So alkanes, they all burn with an unluminous flame. So if you are to say non-luminous, non-sooty, or even a blue flame, that will also be a correct response. So they burn with an unluminous flame. In excess or air or in excess oxygen, they will give us carbon dioxide plus water as the products. So in excess air, we will get carbon dioxide. But in limited supply of air or limited supply of oxygen, we are going to get carbon dioxide. Okay, so both in limited and excess supply of air, the flame is non-luminous. So we are going to see the blue flame, okay? Then for limited, we produce carbon dioxide. So for example, if we want methane, methane burns in excess air with an unsooty flame or with a non-luminous flame to give us carbon dioxide. That is if the supply of oxygen was enough or was in excess. So this is the chemical reaction. We have CH4 plus 2 oxygens. So we have we will form carbon dioxide and water. Then if the air is limited, we are going to have carbon dioxide and water. Okay, then we look at chemical property number 2. This is what we call substitution. Substitution reaction is a reaction where hydrogen atom, we remove a hydrogen atom and then we replace it with another, we give it another branch. So it can be a halogen. So substitution is when we remove a hydrogen and replace it with a what? A halogen. And this must be in presence of a UV light. UV light is ultraviolet light. So alkanes react with halogens in presence of UV light to form halogenoalkanes. So during substitution, the halogen molecule is split into free atoms or free radicals. Remember, halogens exist as molecules. So the first thing during substitution, or when we expose this to UV light, the halogens, they will the first thing is they will split into free atoms or into free radicals. The second thing, one free halogen radical will remove one hydrogen from the alkane, leaving an alkyl radical. So that one free halogen will remove the hydrogen from what? From the alkane. Then the alkyl radical combines with the other free halogen to form a halogenoalkane. So one radical will combine one halogen radical will combine with the hydrogen that has been removed, and then the other hydrogen, the other halogen will combine with the alkyl that has been formed in the alkane. Okay, then the chlorine atoms substitute repeatedly in the alkane, so it does not stop. as long as we have another halogen, it will continue to break and combine with the alkane repeatedly. So it does not leave an alkane until all the hydrogen atoms has been replaced. So each substitution removes a hydrogen atom from the alkane and form a hydrogen halide. Substitution stops when all the hydrogen in the alkanes are replaced with the hydrogen. And the reaction, the substitution reaction, is explosive in presence of UV light, and the catalyst, it reacts as the catalyst. The UV light acts as a catalyst. We can look at some examples. For example, if you have methane, methane has no effect on bromine or chlorine when it is diffused in darkness. So we have to expose this to UV light. So when it is exposed to UV light, methane explodes to form a colorless mixture of chloromethane and hydrogen chloride gas. So the pale green color of chlorine gas fades. So chlorine gas is green. It continues to fade as the methane takes the chlorine radicals, okay, during the substitution reaction. So this is what happens. So we have the chemical equations. So the first step, it will break the chlorine molecule to two chlorine radicals. So one will join the alkyl, that is CH3, and then the other chlorine radical will join the hydrogen that has been removed from the methane to form a hydrogen chloride. So the reaction will be methane plus chlorine to give us a chloromethane plus hydrogen chloride. Then you say that it does not stop as long as we have replaceable hydrogen atoms. So the process continues. So the other chlorine will also split into two radicals, then replace another hydrogen. The process continues. Now this dichloromethane breaks again to give us another chlorine to give us a trichloromethane. So you can see it will split, remove one hydrogen here, then one chlorine attaches to the dichloromethane to form trichloromethane, then and hydrogen chloride. So the last step will be the trichloromethane will react now with the chlorine. So the chlorine gas splits again into two radicals. One attaches to the trichloromethane. The other radical, it joins the hydrogen that has been removed to give us a hydrogen chloride gas. So this is the tetrachloromethane will be the last one. Now we cannot break this one again because the chlorine cannot be replaced. So all the hydrogen atoms has been substituted with the chlorine gas. So this is the process we are calling a substitution reaction, where a halogen replaces a hydrogen in the alkane. So we are going to give more examples on substitution reaction, and that will be in our next part. That will be part 5. So see you in the next lesson.